Okay, now we're going to try and sketch this graph. We're going to try and sketch this graph. Well, you know, it shouldn't be between minus 90 and 90. Now, one thing I hope everybody got was this 2 cos x, because you have to know that the period of cos x is 360 degrees, so between minus 90 and 90, it'll only be half a wave. And you have to know that the cos x starts at 1, but this one's 2, so it's 2 times the cos of 0. When it's 0, there's 2 right there. And then at 90, it goes back to 0. And at minus 90, it goes down here. It almost looks like a parabola, but it's not. It's just a little piece of the cosine graph. 2, that's how tall it is between minus 90 and 90. And you'd have to make sure, there's one thing kind of missing here that I should put in. I want to make sure there's a 2 there, because you have to label the intercepts. And there's a 2 right there. It's got to be labeled. 2, minus 90, and 90. Well, that's an easy 3 marks. Some people don't spend much time working with tangents, so this might be a little hard. But the first thing shouldn't be too hard, because you know that when you have a 2 here, the normal period of tangent, something happens every 180 degrees. But now we go 180 divided by 2, then it will be, instead of 180, it'll be 90 degrees. Now if you put in 0, the tangent of 0 is 0. The tangent of 1, the tangent of 45 degrees is 1. So this one right here, you'd put in 22 and a half. So where 45 degrees is normal here, we have to put 22 and a half in here to make 45 and to make that 1. And negative 22 and a half would make it negative 1. If you put in 45 degrees, your calculator will say error. That's why you've got an asymptote here at x equals 45 degrees. And the period is 90 degrees for a complete tangent wave. So because it's 180 divided by 2. That's the big trick. And you have to know these waves go like this. Now, that takes us to minus 45. Then we'd only have a little branch here. This isn't actually an asymptote. I wish I hadn't put it there, because it's just minus 90 degrees. There's another asymptote over here at minus 135. And another asymptote at 135 here. But there's those 2 asymptotes here. That's the tangent wave. That's what it looks like. And we've got all the intercepts right there. The main asymptote is this one here. That's not an asymptote. In fact, I'm going to get rid of that. That's not an asymptote, and neither is that. The only asymptotes here are x equals minus 45. That's the place where tangent can't touch. It can touch at minus 90, and it can touch at 90 degrees. That's fine. But not at these, it can't touch at minus 45 and 45, but it can touch at 90 and minus 90. And that's the way tangent waves work. Well, there it is sketched. I had a nice computer to sketch it, but that's what it would look like. What's the period of the function f if we go x divided by 2? Well, that's like f of 1/2 x here, 1/2 inside here. Well, if we do that, we know that here we take the regular period, which is here it's 360. We divide by 1/2. Hey, the new period's going to be 720 degrees. So that's what that does. Putting 1/2 there, it's like putting 2 there. Putting 1/2 there makes the period, you divide by 1/2, it makes it twice as long. Okay. Now here's the tricky part. Write down the asymptotes of a new function, g of x minus 25. You have to be careful here. I looked at this and went, it's 25 degrees to the right. But no, you've got to take this x minus 25. It's function notation. You got to put it in here and go 2 times x minus 25. Your new function is 2x minus 50. So the asymptotes are going to shift 50 degrees to the right. Well, you've got this minus 45 shifting 50 degrees to the right. There's one of them, x equals 5 degrees. But there's another asymptote over out here at minus 135 degrees. If we add 50 to minus 135, we're going to get minus 185. So it's minus 135. That's where this asymptote is. Add it to 50, it's minus 85. Those two fit into this region. If we add 50 to these, to the 45 degree one, it just goes out. And that's not an asymptote. So these are the only two that work. Well, that question, I think it was maybe a little challenging, especially the stuff so easy to get mixed up or messed up.